All right, this is a lesson on sigma notation. So another kind of mathematical notation. Why so many different notations? Well, as mathematicians were formulating and discovering new things about math, they got tired of writing out really long sentences, and so they came up with this notation so they could condense their writing down. Think back in the day, paper was expensive and very rare, and so they wanted to use up as less room, least amount of room as possible. So sigma notation was formulated by a mathematician named Euler. His name is spelled E-U-L-E-R. Very famous mathematician. You'll be hearing a lot about him as you progress through mathematics. So he didn't use this notation because it matched the first letter of his name, because they're actually not the same letter. This is an E, this is a capital S in Greek. So sigma notation, capital S. I know it doesn't really look like an S, but it's a capital S. Lowercase s in Greek looks like this. So neither of them really look like the S we use in English. But the Greeks did a lot of work in mathematics, so we use the Greek alphabet often when we're using mathematical notation. So what is sigma notation? Don't let it freak you out. You already know how to use it. Okay, so let's take an arithmetic sequence. If you want to know the nth term in the sequence, you plug into this formula. Okay. So if the first term is 5 and the common difference is 6, then I'll just get 5, 11, 17. But if I want to know a number way down at the end of the sequence, I can plug into this formula. That'll give me the nth term. And we call this a sub n notation. If I want to add up all the terms in the sequence, that's called a series. Here's our series formula with s sub n notation. Okay, so all sigma notation is doing is replacing s sub n notation. Here's how it works. You make the sigma sign, then at the bottom of the sigma, you say, where does the sequence start? All right, so notice what is after the sigma is the a sub n formula. So you're kind of taking the two formulas and combining them together into sigma notation. So that's kind of the power of sigma notation. It combines the two formulas. So this will tell me start by plugging in 1 for k. Well, 1 minus 1 is 0, 6 times 0 is 0, 5 plus 0 is 5. That gives me the first term in the sequence. All right? And then the top of the sigma tells me how far I want to go, like how many of these terms do I want. So here we just have n, meaning we want to go to the nth term. Now usually when you see sigma notation, this will actually have a number here instead of the letter n. And that number tells you when to end. All right, so if I wanted 4 terms, I could put a 4 here. That would tell me start by plugging in 1. So when I plug in 1, I get 5. When I plug in 2, 2 minus 1 is 1, times 6 is 6, plus 5 is 11. That gives me the second term. And since it's sigma, it's telling me add them together. Okay, then I put in 3 for k. That'll give me 17, and then put in 4 for k. Or in other words, if I wanted the 4th term, then that would be k now becomes n. Same thing for a geometric series. Here's how to get the nth term in a geometric sequence. Here's how to add up all the terms in a geometric series. And then sigma notation again combines the two. So we're going to take this part and put it after the sigma, and then this tells me where to start and where to end. So again, if I wanted to add up, like let's say the first 4 terms, When k is 1, 1 minus 1 is 0. Anything raised to the 0 is 1 times 4 is 4. That gives me the first term. If k was 2, 2 minus 1 is 1. 1 half to the 1 is 1 half. 4 times 1 half is 2. That gives me the second term. I just keep knocking k up one higher, one higher, one higher until I get to the end. So whatever's on top of the sigma is whatever is the last number that you're going to plug in to the formula. Then once you have all your numbers, you add them all together. Well, what's the easiest way to add all these numbers together is actually to use this formula. So it's just one more way to talk about sequences in series.